All right, we're on 1-3, solving equations. We're going to talk about some properties for any real numbers a, b, and c. The first one is the reflexive property. So I think of my reflection in the mirror. When I look at my reflection in the mirror, if I'm not like moving, I just see myself again. So for example, a equals a. That's the reflexive property. I would write down reflection. You see yourself, if that helps you, right? Symmetric, if a equals b, then b equals a. So what happened was it switched sides. Symmetric, switch sides. Symmetric has an S, switch sides has an S. Okay? Transitive, if a equals b and b equals c, then a equals c. So basically, if the first thing equals the second thing, and the second thing equals the third thing, then the first thing equals the third thing. All right? Substitution. You guys all know what substitution is. Substitution, if a equals b, then a may be replaced by b. We substitute all the time. You guys know that. And we need to add on page 19. Page 19. There are addition, subtraction, properties of equality, and multiplication, division, properties of equality. So I'm going to say addition, subtraction, property of equality, and multiplication, division, properties of equality. Okay? So you have an addition property of equality. Go to page 19 in your book. Okay? Your addition property of equality is if you add something to both sides, then it's still equal. So for example, if I have, I don't know, 2 plus 4 equals 6, right? If I literally write down 2 plus 4 equals 6, if I add 1 to this side, I now have 7, don't I? So I have to add 1 to this side. You guys have known that one for forever as well. What you do to one side, you have to do to the other is really what this is saying. So if I add something to one side of the equal sign, I have to add it to the other. If I subtract something from one side, I have to subtract it from the other. And the same for multiplication and division. All that's saying is if you add the same thing to both sides, it's still equal. Okay? So here are all the different words that we use, the fancy words, I suppose. Addition, you can call it plus, total, sum, added to, more than, like 4 more than 5 is a plus sign, right? Subtraction, minus, difference, subtracted from, less than, multiplication, times, product. You guys have known product for forever. Division, divide, quotient, okay? Let's see here. So, write an algebraic expression for each verbal expression. So what they've done is they've written it out in words, and they want you to write it with just like numbers and symbols, all right? The product, so we have to think about what that means, of 12 and the sum of a number and -3. So product of 12 and the sum of a number and -3. So what they're trying to say is that the sum of the number and -3 is like together. So we'll need parentheses there is what I'm saying. So the product of 12 and something else. When they say the word and, I know that some people think a plus sign here. That's not what they mean. When they said product, they mean multiplication of this thing and this thing. So the word and here is not indicating to add. Okay. Some number, I'm going to call it x, and -3. So actually the way that they said it is product, so two things being multiplied together, 12, the sum, that's this guy, some number, a number x, y, z, whatever you want, and -3. So sum means a plus sign, so I had to put a plus sign there, even though I don't like a plus and a minus right next to each other. That's technically what they wanted, okay? 23, the product, again, that's multiplication, of the square of a number and 8. So I'm going to take the square of a number, not square root, okay? The square of a number times 8. I don't like 8 behind it. I prefer it in front. But technically, if you said x squared times 8, that would be the same. So does everybody understand it's a product because it's multiplication, right? The square of some number, x, and 8. So again, the word and here is not indicating addition. They mean the multiplication of two things right next to each other. Okay? Name the property illustrated by each statement. Oh, just kidding. I wanted to add one. Go back up here. I'm going to add an example right here real quick. I wanted to add this question. The quotient of, I'm out of room, but you guys get it, 5 less than a number and 12. Okay? So let me erase that because that's annoying. Oh, there it is. Goodness. That was from before, okay? So my answer to this one was 8x squared. The quotient of, this is a new question, the quotient of 5 less than a number and 12. So quotient means what? Quotient's division, right? So the division problem of 5 less than some number and 12. So automatically I'm going to draw a division sign. 5 less than some number is going to be my numerator. 12 is my denominator. And if they say 5 less than a number, that's n minus 5. This is 5 less than some number. Okay? Name the property illustrated by each statement. If g equals 3h and 3h equals 16, then g must equal 16. So what that means is if one thing equals a second thing, that same second thing equals a new third thing, then 1 to 3. Do you guys see what I'm saying? If this equals this and this equals this, then this must equal that. So that's called the transitive property of equality. If I go back up, you can see what I mean. That was this one. If the first thing equals the second thing equals the third thing, then the first thing equals the third thing. It means if this is equal to that and that is equal to that, then they must have been equal to each other in the first place. Okay? If you need an example with numbers, let me know in class, and I'll show you something really easy and you'll be fine. If negative y equals 13, then negative y equals negative 13. All I'm asking you is basically what happened, okay? From here to here, it looks like they multiplied by a negative on both sides. So wouldn't that just be multiplication, right? They literally multiplied by a negative 1 on both sides of the equal sign. Letter x. If xy equals 28 and x equals 7, then 7y equals 28. What happened from here, before the comma, to here? Well, they replaced x with a 7, right? If you replace something with something it's equal to, that's substitution. So they literally replaced x with a 7 because that's what this said you could do. So it was substitution. This is not the transitive property because it doesn't say xy equals 28 and 28 equals 7 times 4 or something like that. It doesn't say that. It's not 1 to 2 and 2 to 3. That's a whole different thing. Again, if you don't get it, please let me know in class. No big deal. Solve. You guys know how to do this. We're fine. Solve each equation. So obviously get the variable alone. So on this one, I'm trying to get y alone. Whenever you're solving, you obviously want to simplify each side of the equal sign before you start moving things, I would say. So for this one, I'm going to go ahead and combine like terms. I'm going to combine all these y's before I move anything around. So what is 7y minus 2y? And then add 3y to that. So 7 minus 2 is 5, right? So 5y. Plus 3 more is 8y. So this is 8y plus 4 equals negative 20. Now I can start moving stuff around. This guy's alone. He's a constant, not a variable. He's a constant, so you need to bring his buddy over. What's the opposite of a positive 4? You have to get rid of it by subtracting 4, and what you do to one side, you have to do to the other. So 8y equals negative 24 at this point. What's in the way of the y being alone? 8. What's it doing? Multiplying. How do we undo multiplication? Division. If I divide by 8 here to get y alone, I have to divide by 8 here. So literally 1y, that was my goal, is equal to negative 3. If you wanted to, you could check it. You could substitute all these y's for negative 3's and make sure this left side of the equal sign gave you negative 20 because that's what it says it should be, right? But we're not going to do that, but that's the answer. Okay? On this one, what is this property? Distributive. Everybody's so good at that, okay? Distributive property. So I'm going to go ahead and distribute 2/3 to the 6c and the negative 18. You could use a calculator if you want to, but 2 over 3, to remember, times 6 over 1. That's what this basically says with a C there too, right? The 3 goes into 6 twice, so I'm just left with a 4C, right? You could use your calculator, but whatever. A positive times a negative, the 2/3 times a negative 18 is a negative sign. So what's 2/3 times negative 18? That's going to be the 12. I already put the minus sign there, right? Two positives, 3 over 4 times 8 over 1 with a C. Two positives make a positive. That's going to be 6C. Use your calculator if you want. 3 over 4 times 32 is 24. And that's still equal to negative 18. Okay? Combine like terms before you move anything. I usually start with the variables first, I guess, or whatever comes in front. It really doesn't matter. So I'm going to go ahead and take the 4C and add 6C to it because that's what it says to do because they're on the same side. So 4C and 6C is 10C. Okay? And then I'm going to use my negative 12 and 24. And what does that make? Negative 12 plus 24 is positive 12. And it's still equal to negative 18. So here it looks just like this question did. What you need to do is get C alone. The way to do that is to do PEMDAS backwards, or basically whatever's farthest away from the variable, do that first, okay? So do I need to get rid of the 10 or the 12 first? So if you're doing PEMDAS backwards, addition subtraction comes first. So I'm going to get rid of the 12 first. It's also farther away from the C. 10 is attached to it, and the 12 is farther away, I guess. So how do I undo a positive 12? Subtract 12. That makes 0, right? And what I do to one side, I have to do to the other. So I'm left with 10C equals negative 30. Now the 10 is in the way. It's being multiplied by C. So to undo multiplication, we have to divide. So C equals negative 3. If this was a test or a quiz, I would expect you at the end, if you had time, okay, to plug C back in, to substitute C back in, and see if the left side equals the right side. And you could basically tell me if you got it right. Solve each equation for the specified variable. Y equals ax squared plus bx plus c. We're solving it for a. What I do is I either circle it or draw an arrow, because when there's more than one variable, it's a little bit hard to remember what you were solving for, okay? So if I'm getting A alone, basically all this other stuff needs to move. I'll deal with this later because it's attached to it, right? But this stuff needs to go away. How do I get rid of a plus anything? I'm going to subtract it, aren't I? I'm going to subtract this to make it move, and I'm going to subtract this to make it move. If I subtracted bx from the right, I have to subtract it from the left side. And if I subtracted c from the right, I have to subtract it from the left. So I had a y, I subtracted a bx, and I subtracted a c. And the ax squared is still hanging out, okay? Now, I want a alone again, right? What's in the way of a being alone? The x squared. What is x squared doing in regard to a? They're multiplying each other, right? To undo multiplication, you divide. So I'm going to divide both sides by x squared. So my final answer is y minus bx minus c over x squared equals a. I got a alone. There's nothing else there. It's 1a to the first power. Those can be tricky for people. So if you need me to show you again, or if you need to rewind it or something, feel free to do that, right? If you have any questions at all, make a note in here for me and let me know tomorrow.